Alright, so we're going to keep going with more free response questions. I've got one more from 2000 that we haven't done yet, and then you guys will have the rest of the 2000 free response questions finished for homework. We already did one yesterday for the sample, so it ends up being 4 problems for homework this time around. But you guys will have the weekend to work on it as well. So this time we're still working with rates of change, but instead of doing it analytically, we're going to start working graphically. We'll quickly throw up a sample from earlier this year. Okay, so I've got here a graph of the velocity of an automatic vacuum cleaner in meters per second. The first thing I want to do is find the distance that the vacuum cleaner traveled in the first 5 minutes. So I'm going to split up.
I don't see the screen moving.
Okay. Do this. I'm going to shut the VPN really quick. And I'll call you back. Okay, we'll see if this helps. Okay, is that any better?
Yeah, better, thank you.
Okay, cool. So, what I'm going to do is I'm going to split this up into different areas. So for instance, I've got an area here. Okay, so area, and another area down here. Okay, so this area in yellow I could split up into this triangle, this trapezoid. This area in green, I've got a box, and then I could cut out the circle that is here. This area in blue is another triangle.
I think the screen is stuck again.
Okay.
Sorry. It left at 2:39.
Alright, I don't think that one's my end, unfortunately. I think that one's your end then. So clear the network already.
I just join. I should join again. I can rejoin. See if it works.
Go for it. So we've got this triangle, which is a 2 by 3 triangle. So that's half of 6 is 3. This trapezoid, I've got my rectangles here, so that's 1, 2, and a half is 2.5. So total in green, I've got 5.5.
Not working.
Okay, for this part in pink, we've got the whole box, which is 4 units. And then this is 1/4 of the area of a circle with a radius of 2. Okay, so the circle with a radius of 2 would be pi r squared is 4 pi. 1/4 of that is pi. So in pink is 4 minus pi. Okay, in blue I've got, this is 2 by 4 is 4 units, and it's below the x-axis. This is negative. And then in yellow is another 4 units is negative. So if I want to find the total distance that the vacuum cleaner traveled in the first 5 minutes, what would I have to do?
Just add the 3 plus 2.5 plus 4 minus pi.
Perfect. So because this is velocity, my distance traveled is going to be the integral of the absolute value, which means all of these areas should be positive. However, when taking that absolute value, this 4 minus pi is still just 4 minus pi because that minus pi is cutting out the white space, which we still don't want. Okay, so that gives me 5.5 plus 4 is 9.5 minus pi is my total distance traveled in the first 5 minutes. If I wanted displacement after 8 minutes, what would I do instead?
Minus 8.
Okay, so everything we just did minus 8 because displacement does allow the negatives to stay negative. So this would be 9.5 minus 8 is 1.5 minus pi. Would be my displacement after 8 minutes. And then for acceleration after 6 minutes, what could I do? Junho, how could I find acceleration after 6 minutes?
Look at the slope.
Look at the slope, okay, because this is a velocity in terms of time graph, if I derive it in terms of time, I get acceleration. So my slope at 0.6 should give me what we want. So here's our point at 6, which means I'm on this line where the blue area is. I went down 4 and over 2, so my slope is rise over run is -2. Okay, perfect. So our acceleration is -2 and then whatever our units will be. Okay, so let's try the rest of this free response. Oops. Okay, so we've got 2 runners here. Running on a straight track between 0 and 10 seconds. The graph above shows their velocity for runner A. The velocity for runner B is given by this function down below. Okay, so here's velocity B, and this is velocity A. Okay, I want to find velocity of runner A and B at 2 seconds, and then indicate the units of measure. So
where's velocity A?
Velocity A is our graph.
Oh, okay.
Okay, so if I want velocity of A at 2 seconds, what can I do?
For B, we can plug in 2.
Okay, for B I can plug in 2.
And solve it. And for A, we read it out of the graph.
Right. What will I be looking for in the graph? The integral, the y value, or the derivative?
I look at the x graph 2 and then look at the y is on 6.
Okay. So that would be here-ish. If I want to go a little bit more exact than that, I could look at what the slope is, and then we can just plug in 2 for our slope. So right now I've got, this point is 310 was given. So that means between 0 and
Yeah.
3, we had a rise of 10 and a run of 3. So my slope is 10 over 3. And then we did that for 2 units. That should give me the exact y value. Okay, so that's 20 over 3.
Oh, okay.
And then I can solve this one as well. This is 48 over 7. Okay, what are my units?
Meters per second.
Meters per second. Okay. Okay, I thought one of you were rushing me, but that's not it. Okay, so I'm going to keep going. My acceleration of runner A and acceleration of runner B at 2 seconds, and then the units of measure. So Junho, over to you. How can I get the acceleration of runner A from the graph?
The slope.
Okay, so that's the slope at 2 seconds. What is the slope?
10 over 2.
10 over 3. Okay, and then for runner B, how can I get the slope from this velocity?
We drive and
Okay, derive it, you're right.
plug to
Awesome. Derive and plug it in. Okay, so I'm going to derive this. AB at t equals v prime. So that is, if I derive this with quotient rule, what's going to happen?
24 times 2t plus 3 negative minus 24t times 2 over 2t plus 3 square.
Okay, so I've got 24 times 2t plus 24 times 3 minus 24 2t over 2t plus 3 squared. Okay, if I simplify, what will I be left with?
Uh, 72 over 2t plus 3 square.
Okay, then I want to find this at 2. So if I plug in 2, what do I have?
72 over 7.
Okay, 72 over, not just 7.
Oh, 7?
This was quotient rule, so the bottom is squared.
Oh, 49.
49, okay. And what are our units?
Meters square. Meter per second square.
Meters per second squared, perfect. Okay, so that's part 1 and part 2. Okay, any questions on A or B?
No.
Okay. Then part C, last one. I want to find the total distance by runner A and total distance by runner B traveled on the interval from 0 to 10 seconds and indicate the units of measure. So let's see if I still have Oliver really quick. Yep. Okay, so Oliver, what's going to happen for my total distance for runner A? Okay, I've lost his mic, I think. Junho, what can I do for total distance?
Oh, hello.
Oh, hello.
Oh,
Welcome back.
Sorry.
Okay.
I said you just multiply 3 times 10 divided by 2 is 15. Plus 10 times 10 is 100, so 150 meters.
Okay, not quite.
So we have to integrate and find the total area of 0 to 10.
Okay, total area. So what's my area for this part?
15.
Okay. And what's my area of the other part?
100.
Not 100. How much is from here to here?
Oh, I see. 70.
Okay, so this is 70. Okay, cool. So what's my total distance?
85.
85.
Meters.
Awesome. Okay, and then what would I have to do for the runner B?
Integrate.
Okay, I need to integrate, and I need to be careful here. We're looking for our total distance, not the displacement. So I'm integrating what?
The absolute value.
Integrating the absolute value of VT from what to what?
0 to 10.
From 0 to 10 dt. Okay, cool. So if we are with a calculator, then I can skip straight to the answer. If we are not with a calculator, then I would have to figure out when this equation is negative. When this equation is negative, I will split the integral so that I can multiply that negative part by -1. However, I believe this VT is positive on the entire integral looking at this. So I don't think that'll end up being an issue for us. But let me show you how to type it in the calculator regardless. Okay, so if I wanted to integrate this in the calculator, I am integrating, so that's math 9. The absolute value, math number, so scroll over to the right there, and then ABS is absolute value. Okay, the absolute value of our function of VT, so that's 24t divided by, we put this in parentheses for the bottom part, it's 2t plus 3. Okay, close one parentheses for the bottom of the fraction, close one parentheses for the absolute value. Okay, in terms of x from 0 to 10. And then that last parenthesis is closing the integral. Should give us an answer. Okay, so this is, our distance is 83.336.
Meters.
Meters. Alright, so let's see how we did. Okay, so for that, I'm going to work backwards since that's what we just did. Okay, distance. Okay, we've got a method and an answer. Distance, an integral and an answer. Okay. Acceleration for A was the slope 10/3. Okay, acceleration for B was 72/49. That's good. Velocity for runner A was 20/3. That's okay. And velocity for runner B is 48/7. Awesome. Any questions on what we did?
I'm Mr. Brandon.
Jinho?
Do we necessarily like change them to decimals?
I don't think it's necessary for this class, no, but you do need to make sure you write your units.
Okay.
If you keep going for physics, they'll usually want you to write in decimals. For calculus, they usually prefer fractions because you're not rounding at that point.
Okay.
Okay. Break out of this, and then for the homework. Okay, so I sent the free response questions from 2000. We've already done question 2 today, and we've done question 4 yesterday. So for this weekend, due on Monday, will be the rest of the questions. So that's 1, 3, 5, 6 from 2000.
Okay.
All right. Thank you very much for coming, and have a good weekend. I'll see you guys next week. Oh, wait, one more thing.
I have a question, Mr. Brandon.
Yes.
You wrote in the Wildcat group chat that starting next week the school is moving to standardized all of the classes.
Right.
About what does it mean?
So I'm going to pull up our schedule really quick. It's actually what I was going to wait for. So our times are changing for the e-learning. So all of your classes are going to have a 1-hour window where they can give class. Our class is block 2, so instead of starting at 10:30, we need to start at 10:05, according
It's
to
not
this.
10:05.
Yeah.
Okay.
So I'll be calling you at some point around then. Your teachers will all be giving some form of live lesson, either through Skype or through Zoom, or through WeChat conferencing. So for every one of your classes, you should have something like what we're doing right now. Where it's like 15 minutes or so of
Oh, okay, then that's good. That's
video
better.
where you're on the chat. And then we're supposed to split between classwork and homework as well for our assignments.
Do we need Wildcat? Wildcat time
Um,
health check-in.
your
Okay.
Wildcat time is
I'm
a
gonna
health
have
check-in,
Wildcat.
but we're supposed to get the check-ins before 9 o'clock and then
Yeah.
send those to Merck for attendance now. So please make sure you give me your health status and location.
Okay.
And I'll try to remind everybody next week before
Okay.
9 o'clock. Okay.
Okay.
Junho, any
And
questions about the schedule? Or,
I haven't. No, but like from the homework yesterday, I had issues with the last one. The second one. Wait, I'm gonna send it.
okay, let me see if I can pull it up. It will pull up scoring
This
guides.
one, number C. I send you on
On the Skype chat. Okay.
on WeChat.
Oh, on WeChat. Okay. Can you tell me the question number?
Number 2.
Number 2. Okay. Okay, so we're told there is some number k such that when r is revolved around the line y equals k, the resulting solid has the same volume as the solid in part b. I want to write but not solve an equation using an integral expression that we could use for k. Part b was the volume of the solid generated by revolving r around the x-axis. Can I edit this so I can write? No. That still doesn't let me write. I have to take a screenshot and write on top of the screenshot, I think. Let's just paste it into the slide.
Does it mean that I just change the the disk method to shell method?
Okay, this is line y equals k. So there's some value here, y equals k, where if I revolve this area about this line, the volume will end up being the same as b. So let me get the volume for b really quick first. I want to revolve this area about the x-axis for part b. So that is this method. So this would be pi times the integral from, if this is y equals 4, I'm going to hit that at x equals 2 and negative 2 of so I've got a top function and a
Wait,
bottom function.
I'm gonna
So
rejoin because I don't see this.
okay.
Oh, it's fine.
So that's 4 minus x squared. So I'll do r1 squared minus
But I already
r2
did
squared
E.
dx. Okay, so I need b in order to solve for c because they said write an equation for the integral expression.
Okay.
So if this is our integral for b, then I can take that integral for b, pi times the integral from negative 2 to 2 of 16 minus x to the 4th dx, and set this volume equal to a new volume with some value k that we're using this method for. So if I'm going to revolve this area about this new line y equals k, okay, my inside function is 4, my outside function is x squared still. So my shell method looks like pi times the integral from negative 2 to 2 of k minus 4 is my inside function, and then k minus x squared is my outside function. Okay, so that's the expression I could use, that I would use. It said write but do not solve, so I don't have to solve it. Any questions on what I did?
Okay, but I don't really understand
Okay, so let me draw out what I just
why
did
we
then on the graph.
subtract x. Yeah.
Okay, so this distance from my axis of rotation, which is at y equals k. Distance to my innermost function is k minus 4 units, right? So here's y equals 4, and this is k. So my distance between them is k minus 4.
Okay.
Okay, so this
Yeah.
is distance to the innermost functions. This is R2. And then my distance to the outermost function would be this distance,
Okay, I see. I understand now.
which is, yeah. So this distance would be k minus x squared would be R1. Okay, then we plug that into our disk method formula.
But do
and
we
hit our
have
sum.
to subtract k minus x because x is already at the point of 0?
It's k minus x squared for this function. And as I go through, what that value of x squared will be will change. So at x equals -2, this value is going to
Okay.
be at y equals 4. At x equals 0, the value will be y equals 0.
Mhm.
And that's actually going to increase my distance as much as possible at 0, and then as small as possible at -2 and +2. But that distance is going to change for all of those values between those, right?
Okay.
Okay, any other questions on this one?
No.
Cool. It's a little bit tricky, but we didn't have to solve it, so you can just leave it like this.
Okay. Thank you.
This is C and B. So you can leave that for the notes. Okay, so thank you very much for coming, and I hope you guys have a good weekend.
Okay. Thank you.
Weekend.
Bye.